Okay, we're going to look at perfect square trinomials, and specifically how to build one if they've given us two parts of a trinomial and we're kind of missing the third part. A perfect square trinomial is kind of broken down like this, and it looks kind of funny, but your coefficient, this is usually the letter A, right? This is usually B. Oh, sorry, I should write an X in there. This is not technically right, so there's an X. There you go. And then the last term, C. But in a perfect square trinomial, there is a relationship between the first coefficient, the last constant, and the coefficient of the middle term. And the relationship is that the first coefficient, if you square root it, so you take its square root, which is A, and you square root the third one, which is B, and you multiply them by 2, it gives you the middle term. Okay, it's kind of a hard idea to see. You know what I'll do? I'll reverse one for you to see if this will help. Imagine you have x plus 2, and actually let's use a different number. Let's use 3 because you can see roots a little better with 3. Squared. When you factor a perfect square trinomial, what it is it's two brackets that are identical, and you can represent it by just putting the one bracket squared like we have. The opposite of factoring is FOIL, right? So if I was to FOIL this, I'm going to do it quickly, it'd be x squared plus 6x plus 9. So if we look at this relationship, the root of 1, the root of 9, well that's 1 and 3, 1 times, remember this value 2 times 3 is actually 6. So that's the relationship for a perfect square triangle. That's kind of their relationship. So let's take this information here. The coefficient of A. Okay, we've got to figure out what C would be to make this perfect square triangle. Well, we know this is 1, so I can root it. Okay, the root of 1 is 1. We know we're going to be multiplying by a value of 2, right? That's what this value idea here is. So we're multiplying by 2. And then we have to multiply by another number so that it equals our term here, 8. Okay, that other number needs to be the root of this. Okay, so think of it, we'll call it our B. We're trying to find our B. So we can do some algebra. We'll put this into equation. 1 times 2 is 2, times B is 2B. So 2B, or not to be, that's so funny. Okay, so our B term, we divided by 2, is equal to 4. So the term we need to multiply is 4. But remember, this is not just B, it's B squared. So we'll have to square this value in order to make our C. Okay, so we know that C is equal to 4 squared. So C is equal to 16. So let's kind of take a look, see if this would work. Y equals x squared plus 8x plus 16. Okay, if you, and I'm going to very quickly factor this. Because this is a 1, I just need two numbers that multiply the outside and add to the middle. Well, two numbers that multiply the outside, I already know, are 4 and 4 is 16. And 4 plus 4 is 8, so we get x plus 4, x plus 4. Hey, look at that, it's a perfect square trinomial. Hey, we did it. And that's a little bit of an easier example. This example here is relatively difficult. Okay, we'll start it off the same idea. We need to root the first term. Well, the root of 2 is not a very pretty number. We're going to leave it as root 2 instead of writing on a decimal. We know we need to multiply it by the value of 2. Okay, then by some other number, again, we'll call that number, that's our B, and that has to equal 12. Okay, so here's our B. We've kind of built somewhat of a formula. So 2 times root 2, I don't know if you've ever seen or dealt with radicals. You can kind of write it as 2 times root 2. We just don't want to get too messy. And times B is equal to 12. Well, think of this. If I square root it, it is a whole term. I can't make this a term. So in order to isolate B, I bring this to the other side by dividing. We're going to get B is equal to 12 divided by 2 root 2. I can break this down into a decimal if I really want. This would become 6 over root 2, and then 6 divided root 2. It'd be the same if you just do 12 times this times that. Let's kind of, I just wanted to do it faster. 6 divided by root 2 is a huge decimal, right? And then that value, we'd have to square it. Okay, and when I square this, again, answer squared. Oh, it gave me a really nice answer, 18. I'm going to show you how with fractions I could have done that, okay? I left this as a fraction. I was able to reduce this because this is 12 and this is 2. I divided 2 by both terms, so the 2 cancel out down here. and that became 6. Have you ever seen that before?
Mm-hmm.
Good, excellent. So you've seen that. Remember, from this step, the next thing we did was we squared it. So we knew c had to be this value squared over root 2 squared. Well, when you square something like this, it's essentially multiplying fractions. So 6 over root 2 times 6 over root 2. Okay? And when you multiply fractions, top by top, bottom by bottom, 6 times 6 is 36. And this is where we get rid of our root. This is why it's really good if we can work with fractions. Root 2 times root 2 is 2. Is actually the value underneath. Think of it like this. If I were to go, root 9 times root 9. Well, I know that's 3 times 3, which is equal to 9. So in other words, whenever we multiply our two roots, it just becomes the base number. So it now becomes 2. And I know I can solve this. 36 divided by 2 is 18. Hey, it worked out. So our perfect square trinomial in this case is y is equal to 2x squared plus 12 plus 18. Finding the 18 was difficult because we had to be used to working with radicals, and usually in our grade 10 year or whatever year we're in, we're doing this. We haven't had much experience with that yet.